Imagine looking up at the sky and seeing not just the moon and stars, but a vast luminous ring encircling our planet. This ring would stretch across the heavens, creating a breathtaking spectacle that would be visible from every corner of the globe. It would be a constant reminder of the wonders of the universe, a celestial phenomenon that would inspire awe and curiosity in all who gaze upon it. This captivating sight, familiar to Saturn, could become a reality for Earth, albeit with its own unique characteristics. Unlike Saturn's icy rings, Earth's ring would have its own distinct composition and appearance, making it a unique feature of our planet. Instead of icy particles, our hypothetical ring would likely be composed of rock and dust, remnants of ancient celestial collisions or remnants from the early solar system. These particles would reflect sunlight, creating a shimmering band of light that would be visible both day and night. This ring, a celestial tapestry woven from the fabric of space, would dramatically alter our planet's appearance and potentially impact life itself. It could affect everything from our climate to our night skies, creating new opportunities for scientific discovery and exploration. The presence of such a ring would be a testament to the dynamic and ever-changing nature of our universe. Unlike Saturn's icy rings, Earth's rings would be composed of darker materials like rock and dust. These materials are abundant on our planet and would create a unique visual spectacle in the night sky. The reason for this difference lies in our planet's proximity to the Sun. Being closer to the Sun means that the intense heat would prevent the formation of icy rings, which are characteristic of Saturn. The Sun's heat would cause any ice particles to vaporize, leaving behind a ring composed primarily of more resilient materials like rock and dust. These rocky particles would endure the Sun's rays, creating a stable ring system. These particles reflecting sunlight back to us would give the rings a faint ethereal glow, less brilliant than Saturn's, but still a breathtaking spectacle. The subtle shimmer of these rings would add a mystical quality to our skies, making every sunrise and sunset a moment to behold. The visual impact of Earth's rings would depend greatly on the viewer's location. From the equator, the rings might appear as a thin, bright line stretching across the sky, bisecting the heavens. As one ventured towards higher latitudes, the rings would gradually transform into a more prominent arc, dominating the sky with their presence. Imagine a world where the rings cast intricate shadows on the Earth's surface, creating shifting patterns of light and darkness. Earth's hypothetical ring system would likely orbit our planet within a specific range, dictated by gravitational forces and atmospheric drag. This range is crucial because it determines the stability and longevity of the rings. If the rings were too close to Earth, they would be pulled down by gravity and eventually disintegrate in the atmosphere. Conversely, if they were too far, they might drift away into space. The inner edge of the rings would need to be far enough away from Earth to avoid being pulled down by our planet's gravitational pull. This means they would have to be positioned beyond the Roche limit, where tidal forces would otherwise tear them apart. The Roche limit is a critical boundary for any celestial body orbiting a planet. They would likely reside beyond the Earth's atmosphere, perhaps a few hundred kilometers above the surface. This altitude ensures that the rings remain in a stable orbit, free from atmospheric drag that could cause them to lose momentum and fall back to Earth. The exact altitude would depend on various factors, including the density and composition of the ring material. The outer edge of the rings could extend for thousands of kilometers, creating a vast celestial halo around our planet. This halo would be a spectacular sight, visible from the surface of Earth as a shimmering band in the sky. The extent of the outer edge would be influenced by the balance between Earth's gravity and the centrifugal force acting on the ring particles. Unlike Saturn's rings, which are composed of numerous distinct bands, Earth's ring system might be more uniform in structure, possibly resembling a diffuse disk rather than well-defined rings. This uniformity could result from the different formation processes and material composition. While Saturn's rings are primarily made of ice particles, Earth's rings might contain more rocky debris, giving them a unique appearance.